am Muaz. I from Info G4.
Hi guys, my name is Saripon Nurnisa. I'm from Group G4 People.
Hi, my name is Mira Aini Muhammad Zaid and I'm from G4 People.
Yes, manager, I come from G4 People. This is Tan Hong. I am from G4 People.
Hi guys, today I'm going to present the introduction for our project part 2, which is we are going to determine the size cable for the HEPA building. So in this project, the electrical load distribution system for the building was designed based on the required switch and the socket, SSO, and electrical loads. The layout of the SSO was first determined using the AutoCAD, and the electrical load calculations such as the total load, current, and maximum demand. And based on this result, the distribution board EB, subswitch board SSB, and main switchboard MSB layout were designed to ensure efficiency and proper electrical power distribution. So the objective for this part, which is the cable sizing, is to design the switch socket outlet SSO layout based on user requirement and room functionality. Calculate the total current load and maximum demand to determine the size cable, and to select suitable protective device such as miniature circuit breaker MSB, reschedule current circuit breaker RCCB, and multicast circuit breaker MCC. That's all. Thank you.
So 2.1 is to use a low voltage LV electrical distribution system to deliver electrical power from the main supply to different loads in a building. The system usually includes the main switchboard SSB, sub-switchboard SSB, distribution board EB, and silent circuit. A well-designed distribution system ensures safety, reliability, efficiency, and compliance with electrical standards. The main objectives are safe power delivery, protection from overload, short circuit, and earth leakage, minimizing voltage drop, and efficient power management. So, the definition: electrical installation must follow regulations such as JCR, ISE, PNB, and ST. This regulation ensures that the power system meets legal and technical standards. They focus on electrical safety, proper load distribution, and energy efficiency. Following these guidelines help create a safe and reliable system while reducing risks such as short circuit and electrical fires. So the cable one is cable selection is important to ensure that the electrical system can safely carry the required current without overheating or causing excessive voltage drop. In this project, cable size were chosen based on the maximum demand and required current capacity. The cable current capacity must always be higher than the design current to ensure safety operation. Cable size such as 6 mm, 10 mm, and 15 mm were used depending on the load and installation requirements to maintain system safety and efficiency. Thank you.
Good afternoon. I will explain the procedure used to complete this project. First, we determine the type and number of sockets used in the building. This was done based on the AutoCAD layout plan of the building. From the layout, we identified the direction of electrical load, such as socket, outlet, and other electrical equipment. Next, we use Microsoft Excel to calculate the total connected load, which is here, and maximum demand, which is only. The total connected load represents the total power of all electrical equipment connected to the system. One maximum demand is the estimated maximum load that will be used at one time this calculation, and ensure the electrical system is designed safely and efficiently. After that, we designed the distribution board or EB layout using AutoCAD. In this step, we arrange the circuit and protective device inside the distribution board to ensure proper organization and safe electrical connection. Then we perform the calculation for the sub-switch board or SSB and main switch board, which is MSB, using Excel. The purpose of this
size based on the meter load current so that the cable can safely carry the electrical current. Finally, we calculated the voltage drop for the cable. Voltage drop secure when the electrical current flows from the cable. Therefore, it is important to ensure that the voltage drop is within the interval limit according to the standard. To maintain efficient electrical performance, overall this procedure has ensured that the electrical installation is safe, efficient, and prevent electrical.
Hi everyone, my name is Tan Chen Hong. I will be discussing the result of our project. Our power design for the HEPA building follows strict rules for GIR, ITE, TME, and SP to make sure the system is safe and energy efficient. To figure out the building's electrical needs using two main calculations, which is total connected load TCL and maximum demand IP. TCL is the total power if every electrical item is turned on. We converted this into amps to help us choose the right cables and breakers. Because not all equipment runs at the same time, we calculate the MP. This helps us to ensure expected loads, so we can pick the right safety device without overloading the system. Thank you.
For the next part for the discussion is the flow distribution. For the ground floor, power flow from the sub switch board SSP1 is to connect the 9 distribution board, and the first flow we use SSP2 to connect to the 6 distribution board. On third floor, we use 36 ampere breaker MCCB for each board. We also make sure our cable can handle 38 ampere, which is higher than the load, so it will never overheat or the short circuit. Also, the main breaker for both SSP are 300, so we use the cable that handle 312 ampere. So, what I can do for the conclusion is, finally, we calculated the voltage drop that makes sure the power doesn't get weak as it travels through the cables, and which is make it perfectly for the power supply. In short, our calculation proved that our chosen cable and breaker are completely safe, suitable, and ready for the building electrical load. Thank you.
Guys, my name is Sam Jian. I am going to present our conclusion for our mini project. So, in conclusion, this project is successfully designed and electrical installation system for the HEPA building. So, the layout of the switching, the socket layout was first developed using AutoCAD based on the building plan. So then, the electrical load was calculated using Microsoft Excel to determine the total current flow, TCF, and maximum demand. So based on this result, the distribution, board layout, cable sizes, and protection device such as MCCB, RCCB, and MCB was selected. So on this project, we will learn that how to design a safe and efficient electrical distribution system that will actually detect the electrical load and protection device will meet the required standards. So for this project, we can also improve our understanding of electrical installation design and practical calculations. Yes,